Well, hi, good morning. Thanks for joining me in my shop here on July 20th. Hey, I just watched Jeff Bezos go into space and back. And here is the Bradna radio. This guy, I'm assuming you're watching the series, then this is video number 8. And you know some time has gone by since the last video. It's been, I think, maybe as much as a couple of months. I kind of lost track of the time. So I'd done a fair bit of work on this radio, restoring it, and then found a lot of difficulties in aligning it. I could not align it. And then my last discovery was the oscillator, the local oscillator inside the radio, doesn't work right. That's the best way to put it. Normally your oscillator would start at a low frequency, and as you tune the radio, the oscillator goes up to a high frequency, and that's it. It just goes up like this, back and forth as you tune. This radio, as you tune it down, keep tuning it down, at some point it starts going up again while you're still tuning the radio downwards. What exactly can cause that? That's pretty curious. That's a pretty curious problem. So, interestingly enough, this radio was made in Ottawa. Ottawa is the capital city of Canada, and that's where my wife and I were the last 3-4 days visiting someone in Ottawa. So, and I think this is quite a rare radio. I don't think there's a lot of these around. This one's in really good shape. So it's a bit of an important project in that sense. Well, I think the best thing I can do is repeat the last experiment I was doing. I was using my SDR radio to pick up the local oscillator signal. Then I was tuning the radio and observing the frequency variation, and that's when I discovered that it does this weird turn around and go the wrong way thing. So I'm going to set that up. We're going to repeat that and see that it's real. And then it's all about how can that happen, what can I do about it, how can we make this radio work properly. Okay, well, before I get into this too far, there's something that is jumping right out at me, and it's this component here, which I put in. This I put in thinking it was a capacitor. This may not be a capacitor. Now, there's another component which can look exactly like that, called a VDR, voltage dependent resistor. And I may have picked one without realizing it and stuck it in here. Let's take a look at what this says on the surface of it here. Because I think putting a voltage dependent resistor in a circuit where the radio expects a capacitor would cause some pretty weird stuff. And this radio's doing weird stuff. Let me just get my other... Hey, my other camera's not working here. Okay, gotta get my other camera working. Well, you know, it's not just always the item I'm working on that needs repair attention. So my little camera here has finally given up the ghost. If you listen, the wires failed right here, of course. Well, that's too bad. I don't know what to do about that. I'll certainly attempt some kind of repair rather than just throw it away, but I got no idea what's inside this cable. Bah, what a shame. Okay, that's a new project, but now I have to get another camera out here to use. Son of a gun. Oh, lots of camera and computer problems here, so I'm just down to one camera today. Not really sure what has gone wrong. Well, I know what's wrong with this one anyway. Okay, so let's take a close look as best we can here at what is going on. And you're going to get a view of the back of my head while I take a look at this. Wow, I wish I had this on camera. There's an awful lot to read on here. But there's no size. There's a lot of information on there. There's nothing on the back. I think this is a bad actor. I think I did something dumb there. That's probably the cause of this. So I'm going to figure out what part this really should be and put in a more typical looking capacitor here. Get this guy out. Here's a couple more I have. I have quite a few of these. Some of these are capacitors. They look like this, and they are capacitors. They have a capacitor rating on them. And others are voltage dependent resistors. And frankly, I can't look at them and tell the difference. So we'll get that out, and we'll get a regular capacitor put in there. I'll bet you that's the problem right there. I'll bet you a quarter, 25 cents. Okay, so the capacitor we are talking about is this little guy here, 0.002. It's got some strange letters written there. Can't read it. Wait a minute, yes I can. I missed my close-up camera already. Microfarads. MFD is what that is. So 0.002. So I'll just get a 0.002 capacitor, put it in there where this blue thing is, and we'll see what happens after that. Okay, let's see what this guy says. So this is the part I've taken out, which I put in as a capacitor, but now I don't know what it is. Let's see what this thing says. So it says it's a capacitor, and it's 4,000 picofarad, 0.004. Well, the size that's supposed to be in there, according to the schematic here, is a 0.002. So in the worst case, or in the best case, I've put in a double-sized capacitor, and you know, this capacitor is involved in the audio circuit. How could it affect the radio's tuning pattern? Can't imagine it. So there we are. So that's 22 picofarad, 2200 picofarad, 0.002. I'll put this guy in, but I'm really doubtful it's going to make any difference, but somehow I got the wrong size in there. And this is just covered in writing. This guy. Okay, anyway, I will now correct my mistake, and then we will test the radio and see what happens. Okay, so in the top right corner there you see the frequency display of my SDR radio. The SDR radio is actually this little guy here. That's the SDR radio I'm using. And the antenna connections here. This comes around to this yellow, just a yellow clip lead, just looped up, connected, nothing to it. Sitting in proximity to the radio. I know from experience the local oscillator in this radio, like a lot of radios, plenty strong, should be picked up here. The radio's tuned to around 1 million right now, so the expectation is the local oscillator would be 450 kilohertz above that, so 1450. So if we look on the SDR for 1450, 1450 is right here. Now I'm going to click. You see the red line that is there now, roughly marking 1450. Actually, we make it exactly 1450 here. Not that it needs to be. So where this red line is, we should see a signal show up when I turn the radio on, and that would be the local oscillator operating at its proper frequency. Okay, I think we're ready to go on everything here. Now I was fooling around with the on-off switch and stuff on this radio, and I can't remember now. I disabled the battery connections and forsake them, so we're only dependent upon the plug-in power. Okay, I think we're ready. Radio's off. Let's apply power. Switch off, and nothing's happening. Good. Turn it on. The volume. These radios with these 1-volt tubes tend to come to life really quick. Here we go. That was kind of interesting there, you know. That wasn't a smooth startup. It seemed to me it got sensitive and then the sensitivity went down again. I had to turn the volume up. Just making observations here. Okay, so what happened on the SDR? Way over at the right, you can see something. That would be at 224, higher than 2400. Okay, so I'll tune the radio. We'll see what moves. There we go. Well, that sounded great. That sounded great. maybe changing that fits the whole thing. Then I see the local oscillator was in the range, the proper range, and that thing out at 2400 didn't move. So that's some other signal in my shop here. Who knows what it is? Let's see if we can get a stronger local oscillator signal here. The actual oscillator, I'm not sure. Oh, maybe up here. I mean, it's something there. I'm touching it with my hands. Really not leaping out, is it? Oh. Okay, just interesting stuff that happens, but no local oscillator really leaping out. Okay, we'll put this back down here. I'll tune the radio so we can spot where the local oscillator is. Oh, what was that? Well, that's mighty interesting. Now, the radio's coming to life at a certain spot. Sounds to me like the plates on the capacitor are touching. And I also notice the local oscillator is absent. And then after the crackle, it's there. So watch again, right around the red line there. Get all this volume here. The local oscillator is sitting right in this area. Let's see if I can get a little bigger here. Yeah. There we are. Now we see it loud and clear. Right here. So that's at 16, say 1700. So subtract 500. The radio should be tuned around 1200. And you can see it is tuned around 1200. So maybe that part was the problem. Okay, so the experiment was I tuned it down, and at some point the oscillator started going up again. So we're going to go down and just watch it. Okay, we're going to go up. We're going to go up. Watch it. Now there are other things moving around on the SDR. Don't pay attention to them. Ignore what's behind the curtain. Now we get all the way up to the end. There's the end. Wow, it gets, yeah. So that frequency is 2200. That's way off the range, isn't it? That would be tuning in something like 1800 in the radio. Seems way off. Okay, we'll go to the other end. It's the other end where it went kind of funny. Where'd it go? Oh yeah, it's still doing it. So, okay, so we're coming down. You can see it there quite clearly. Let me turn the radio up so we can hear the effect of it too. Wait a minute. Oh, right there. It just cut off completely. Really weird. I think a closer look at the capacitor is in order here to see if there's trouble with it, and son of a gun, I don't have a good close-up camera to do this with, so it's going to be quite awkward, but it is what it is. I think this camera's on autofocus. It's another hassle. Just detangle the wires here. Okay, so we want to look at the plates. Oh boy, this is going to be tough. This is going to be tough to do. So I'm going to stop and fiddle with my cameras for a while. See if I can't settle this down. Okay, so now we're looking in at the capacitor here. View in the camera isn't quite close enough, I think, to spot a problem, but something worth noting about this capacitor is the outside plates have been bent out. So this one in particular has been bent out. The same thing on the smaller set, which is almost certainly the oscillator set, it's been bent out. And that's part of the factory tuning process, so we don't want to bend those back in. We don't want to bend them out any further either. So what I'm doing is I'm just looking at the alignment of the plates on the rotor with the stator. The problem appeared to be with the oscillator, which I'm pretty sure would be this one here. Let's see. Yeah, so when I touch these stators, the radio gets stronger. I'm pumping in a little more antenna signal from my finger. When I touch these, it goes quiet because I'm killing the local oscillator. Now, where's the funny business? The funny business. Let me turn up the radio a bit here. Doesn't really sound like a short circuit problem. I still hear the radio. I'm picking. Now I'm gonna just look at the SDR result here. Put the coil back in the right spot. Find that oscillator. Right here, right at this mark, the oscillator dies. And if I turn it just a little bit this way, it comes back. You can hear the radio kind of tuning in there. A little further this way. Oh, it's hanging on. No, now it's dropped to nothing. So there's no local oscillator. Let's go back. There it is. Gone. There. Gone. What's happening right there? Now I was looking at the SDR, I wasn't looking at the plates. Doesn't seem to be anything happening there. So another way to do this, you put it right on the edge of the trouble. Right in here, it's just disappearing. I can still see it. When we take something like this, go across the plates, if there is a plate contact, this little movement in the plate caused by the pen can upset it, and you can hear it. I don't hear anything. You expect to hear like a crackle or a pop, you know, a snap, crackle, pop. I don't think there's a short in here. I think we're chasing something that doesn't exist. Usually there's a sharp crackle, you know, and an ending here. Did the oscillator come back at any point? What about that reversing of the oscillator? That happens here. So right from here, that's a little loud. Ooh, that was pretty sudden, wasn't it? There's a click there. I heard a click there. Turn it up again. Well, you know, when an oscillator stops oscillating, it can make these kinds of rather sudden sounds, like almost as if there's a click there. Now, typically oscillators don't oscillate at the high end. Oop, that's the volume. You can see how much capacitor there's got left. All this is dead here. And as for what frequency it's on, so this is kind of the lowest. Oh, wait a minute. It's doing that reversing thing. Let me get this back up on the screen here. Okay, so the area we're watching is right around this 1400 area where the red line is here. First, I'll make the local oscillator quite visible. Okay, so if you look at the waterfall display, that's helpful too. You can see it started right here. Now I'm going to tune the radio. Turn the volume down. I'm going to tune the radio up in frequency, so this local oscillator line we're watching should go up in frequency. There we go. It's going up. It's going up. That's good. Okay. I'm going to bring it back down. Down, 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 down. I swear there was a click at that point. But you can see that it's fading out in strength as we get down there. It's not working properly and then suddenly stopping. It's fading out. Why would you fade out on me? I'm going back up with it. I'm tuning it the wrong way. Tuning it back up. Okay, right at the very end here. Kind of see it on the waterfall display. Right there, there was a click. Does it click on? Click off. Click on, click off. Okay, well, well, who knows? Let me turn this up. Let me get something better here. Thought I heard something there. Well, is the oscillator on at this point? No. Okay, let's get it on. I have it turned up. I don't hear the click. I hear a fade out. It has anything to do with this capacitor at all. Oops. Oh, Doc. What'd you do there, Jim? Well, I'll be, man. Things really came to life now. What happened? Ooh, look at the local oscillator. strong. Yeah, just as I'm saying, no, it can't be the capacitor. Well, that's the volume control. I know that works. Okay. Wasn't that right in here? Oh yeah. We got to get closer and really try to see the contact in there. So that involves some trickery with the camera. I'm going to stop and get that happening. Okay, let's give this a go. Now, sure looks like clearance from what we can see there. I'll tune a bit. Where's the exciting spot? You know what? The problem does not exist right now. What? Really? Turn it up a bit. Pretty close in there. I'll show you where I'm looking. I'm looking right in here. So I pushed a little bit on these plates. This isn't the oscillator plates either. This is the radio receiver plates. I'm pretty sure. That killed it. Now, did that kill the oscillator? That should not kill the oscillator. Let me just look on my own self here. Oscillator, where are you? Oscillator. Okay, oscillator very clear on the screen. And now I will push on the plates here. No effect on the oscillator. That's just what it should do. Nothing. So how can that be the cause of the effect we were seeing? Let's go look at the oscillator plates here. This is really I miss my other camera already. Problem with this camera I'm using right now is it's physically large and it can't be jammed in easily to spots. Okay, that looks pretty good. Let me fix the focus on it here. Just bear with me a second. Okay, again, the problem appears to be gone. So. Son of a gun. Okay. Well, that's not a particularly bad thing. Now I was attempting to align this this radio when I discovered this weirdness. So what state the radio alignment is in, I don't know. Well, okay, let's just watch the oscillator. I'm going to switch the screen over to show you the SDR only. Okay, you'll see where the local oscillator is as soon as I start dialing this. Yeah, there it is. So the radio right now is tuned basically to the bottom of its range. So 550. So 550 plus 450 is a million. So you would expect the local oscillator to be around a million. There it is, right around a million. And if we tune up, it just travels along, doing the right thing, all the way up. Now we're at the top. So the top here, it's 2.2 megahertz. Subtract 450, you're at 1750. 1750, and the dial on this radio ends at 1600, around there. Well, it could just simply be the alignment's not correct. It needs to be adjusted. And maybe that would bring this in, because right now the radio is trying to tune a signal. Certainly when this radio was made, there were no signals at these frequencies. So I'm pretty sure a local oscillator shouldn't be where it is. Okay. Yeah. It's another case of, I fixed it, I think. Yeah, so I think I fixed it. Now, while we're looking at that, I'm going to grab my faithful can of WD-40. I'm going to spray it in these ball bearings here. Just a wee bit. Ooh, that's more than a wee bit. And right in here. Just a wee bit. That's right. And over here. And also right in here. Just a wee bit. So that helps with obviously the ball bearings are about the suspension. But the other part here, this copper part you see is actually a spring pushing against this. This is the rotating shaft. And that metal, which doesn't appear to be springing out, but this no doubt has some springiness to it, is responsible for maintaining the grounding connection of the rotor. The rotors are grounded. Yeah, nothing going wrong here. I guess pushing on those plates must have solved it. It must have been a plate short. Maybe a plate short of high resistance at some point was causing the weird oscillator direction to change. You got me on all that. Okay, I have to stop recording and alter my cameras again. Okay, let's see what we can do with this setup now. I've got the signal generator running. And just for an initial test, we'll set this to 1,000,000. We'll see if we can receive it. The output of the signal generator ends with this red wire here, just hanging near the antenna. The antenna for this radio is actually in the front door up here. That's the instructions. I have the actual written instructions. The engineer who did this took some time to write some interesting information. There's often some interesting, insightful information tucked into these sheets as they share their little secret that they know, that they want you to know about. So, okay, so we're tuned here. Let's tune up to somewhere in here. Okay, we're going to give it a little more power here. Oh, there it is. Let's turn this to 1,000 hertz. I'll just weaken it. Nice. So we're feeding at 1,000,000 and we're tuning at 900, almost exactly 1,000,000. Oh, that's really pretty good. Okay. Now we're going to dial this down to the IF frequency. Okay, you don't hear it. There it is. Let me short the antenna out. Just don't hear it at all now. So in the instructions it says, if the IF alignment is poor enough, you may not be able to receive the signal just by having the signal generator output close to the antenna. You may have to make a connection more directly to the antenna, to the radio, and I believe it's right here where I've just used this clip lead to short it out. Let's try that. Cut down the output. Wow. Oh, this is low. Let's try it again. I would say the IF is tuned at 462, which is a weird number. I'm pretty sure it's 455. I don't think there's any doubt of that. .455, yes, definitely 455. Okay, so we're gonna retune the IFs to 455. Let's go like that. Go like that. I sure don't like the rumbling here. Is it because I'm tuned into something? Yeah. Let's get a quiet spot here. Now, why doesn't that sound like a nice clear tone? Why does it sound so crummy there? Oh, I'm connected directly. I'm not supposed to do that during this. Okay. Volume down. That's right. Take this off. You know what? I can't short the antenna out and then send the IF signal into the radio through the antenna. Can't be doing that. So we'll just do like it says. We'll couple it with just an open wire here. Probably gives instructions on where to have this tuned while doing this. Do not connect the ground lead of the generator. If the IFs are way off, hook up to the tube. Tune the IFs for maximum output. Small insulated screwdriver starting at the end nearest the output tube. If it oscillates or hisses excessively, slightly detune one side. Yeah, you can the IF transformers, the IF circuitry can become so sharp that it will oscillate with itself. Hold the spears. Okay, screwdriver. Itty bitty screwdriver. A little metal screwdriver. Closest to the output tube. I don't really hear any tone at all. Let's put this even higher. Sort of hear it. Okay, let me just start tuning here. Okay, right in. Oh, this is stuck. So I'll get a screwdriver with a fatter handle. Make me a stronger guy, but it's got more metal here. But I don't think it matters too much on a capacitor. Okay. There, I'm trying it now. Wow, it only wants to turn one way. Did I encounter all this already? It seems like the screwdriver wants to cam out. Oh wow. Wow. Yeah, I've done so many radios now, I've got memories of all of them. I can't sort them out. Let's try the other screw. Doesn't seem to be very far out, if it's out at all. I'm not hearing the tone really either. I don't like how this is going. Let's try this one. See, I could be tuning in not the signal generator. I'd be tuning in something else. No sign of the signal generator here. What's happening? This isn't working out. Yeah, the modulation's just a little low here. Put it at 35. You kind of hear the tone. Okay, so we're just doing this by ear right now. Let's start with the screw again that can't seem to turn. I'd make that out to be the best spot. We'll watch the meter in a minute. I have to realize we're trying to feed the IF signal. It's really not intended to come in on an antenna like we're doing it. So the fact that it's weak, not too surprising. Get on there. I don't like how this is going. I think I want to more closely couple the signal generator to the radio. Let's see what we can do here. The antenna, it's in here. Oh my god, my house, we went away for a few days and my house is full of black ants. Can you see them running around up here? There he is. Missed him. I'll get him when he comes out. You guys watch for him. There he is. Too bad for you, buddy. I think I got him right in the head. Murder in my shop. There it is. Killed one of nature's beasts. Now, trying to improve the strength. That's right. I'll make a little loop here. See if this doesn't boost things up nicely. That's a little better. I like that a little better. Much better. Okay. I'm going to start over a little bit. $455. It's way up at 460, 470 rather. Let's see if we can bring it down. Meter sensitive to me pushing on the chassis a lot. I wish I could just set the radio down flat for this. I have to get underneath these? No. Okay, time to rearrange things a little bit to make this easier to do. Okay, I think I'm gonna do a lot better job like this. Start here. Watching the, this is very hard to turn in. This meter's not doing the job here. What's going on? No. So I think maybe we're hearing the effect of, one coil coming into alignment. Let me quickly go through them all here. What's with the jumpy? What's jumping? Too much jumping there. That would seem like it. Don't know why my meter likes to jump. I'm going to pan this back and forth across 455. We'll see what happens. Seems pretty good. Good enough. Okay, we should be able to pick some stuff up at this point. Let's see if we can. best stations are down in this area here on the dial. Oh. I don't know what's with my meter. I don't know. Okay, we gotta get this out of here. Hey, radio, where are you? Ooh, that's dead. Still doing the coming to life up here. But dead. Oh. Okay, we'll carry on with the alignment process, and hopefully that'll bring it back. So the next step, do the RF part. Loosen the locking nut on the oscillator adjusting screw, which protrudes through the chassis between the control shafts. Here it is here. You can see, can you see? Did I do that? The locking nut is almost right off it. It's nowhere near locking anything. Put it down there somewhere. So for some reason this is just loose beyond belief. How do you stick a screwdriver in there? Yeah. Okay, so what now? Read some more instructions before you start screwing around with it. Loosen the nut on the oscillator adjusting screw with the tuning condenser closed. Signal generator 540. Tuning condenser closed. So that sounds like it's not shorted. That sounds like you just hit a short. What is with this guy? When you have shorted plates, they're touching, and as you tune it, the plates drag across each other. Their contact varies, and you can hear that. There's no such noise in here. Okay, let's see what we can do with it. Closed. 540 on here. Okay, put the antenna coil back here again. There we hear it. Oh wow. Oh wow, that's great. It's great because it indicates the alignment is so bad, there's lots there to pick up. Okay, and now we're turning the oscillator screw to get a maximum reading of 540 when the capacitor is closed. That's what we're doing here. I can turn this by hand. Now this is broken. This is broken. I can turn it by hand though. Oh! What happened there? We were doing great. Some trouble turning that with my fingers. Just grab a tool here. I just can't get a grip on it. What's happening? What happened there? Why did that suddenly work and then go away? Because it's an old radio, Jim, that's why. Is that capacitor thing happening? Turn down the signal strength. What are you doing here, radio? Okay, the stick. Quick check of the plates. Nobody complaining. What is going on? I tell you, man. What has happened? We were doing great. Everything was going really well until it wasn't. Okay, turn this back up. What happened to 540? It just went totally away. Why is that? So another way to do this is to look at the local oscillator frequency on my SDR radio and set it that way. And is there even a local oscillator there anymore? Oh my gosh, that's a good question. Let's take a look here. Okay, so I'm just going to swing the antenna leads for the SDR right around here. Where's that oscillator? So the radio's tuned very low, so the oscillator should be around 1,000,000. Well, there is something there, but I'm waving this pickup coil all over the place. I don't think there's any oscillator there again. Okay, I'm going to tune the radio. It's the same thing. As you head towards the low end of the band, the oscillator goes away. I thought I had that solved. Go all the way down to the bottom. I'm trying to make it pop in like it did before. It won't. Okay, back up. It just weakens away, and just slowly tuning up, it just weakens away into nothing. Oh, you little radio. You little radio. It would seem to me that the last 5 or 6 radios I've done have all had terrible bugaboos in them. And have driven me nuts. Come on, man. How come you can't oscillate at a lower frequency? What could it possibly be? What could it possibly be? Careful now, we're going to burn out these tubes. So these particular tube set in these battery operated radios, you dare not pull one tube out while it's operating or do anything like that. And even wiggling the tube can break the contact of the heater. It puts all the other tubes at risk. Potentially burned out like that. Still working though. Oh, that's something new. Where did that come from? By wiggling that tube, I ended up with this. Is this the way it should be? See that guy? That was a brother of the other one. House crawling with black ants. Okay. Boy, I don't know. I just don't know. what to do. I don't know. Oh boy.